Understand the relationship between pressure, temperature, and volume. The behavior of helium gas inside the balloon can be modeled using the ideal gas law, PV equals nRT. Since the amount of helium gas remains constant, N equals 0.25 moles, as the balloon rises, we can relate the initial and final states of the gas using the combined gas law P1V1 over T1 equals P2V2 over T2 to analyze what happens to the volume. We can rearrange this equation to solve for the final volume, V2, as a function of the initial volume. V1 V2 equals V1 times P1 over P2 times T2 over T1. Isolate and calculate the pressure effect. The pressure decreases from 1 atmospheres at ground level to 0.1 atmospheres at altitude. This is a 10-fold decrease in external pressure. P1 over P2 is equal to 1 atmospheres over 0.1 atmospheres equals 10. According to Boyle's law, gas volume is inversely proportional to pressure. Therefore, this dramatic drop in external pressure acts to increase the volume of the balloon by a factor of 10. Isolate and calculate the temperature effect. The absolute temperature of the air decreases from 273 Kelvin to 220 Kelvin as the balloon rises. According to Charles's law, gas volume is directly proportional to absolute temperature. Therefore, this cooling acts to decrease the volume by a factor of T2 over T1 is equal to 220 Kelvin over 273 Kelvin, approximately 0.81. This corresponds to a 19% contraction in volume. Combine both effects to find the net change. Multiply both ratios together to find the net scaling factor for the volume. V2 equals V1 times 10 times 0.81, approximately 8.1 times V1 because 8.1 greater than 1. The volume of the balloon must increase. The massive expansion caused by the 10-fold drop in pressure completely dominates the relatively small contraction caused by the 19% drop in absolute temperature. This identifies option A as the correct answer. The correct answer is option A. The volume will increase because the decrease in air pressure will have a greater effect than the decrease in temperature.